Hi, today we're looking at section 8-1, Factors and the Greatest Common Factor, which we'll refer to as GCF. So take some time to take notes on. Pause the video at any time to write your notes or go back and review a concept, and complete the check it out problems on the worksheet after each of the examples. Our learning targets today, I can write the prime factorization of numbers, and I can find the greatest common factor, or the GCF, of monomials. So we're looking at whole numbers. Whole numbers that are multiplied together to find a product are called factors. So a factor is a whole number. The order of our factors won't change the product. We could say 3 times 4 equals 12, and also 4 times 3 equals 12. In this case, 3 and 4 are two factors, and they happen to be factors of 12. With prime factorization, we're going to look for a number polynomial written as product of primes. And prime numbers, as it says down here, remember prime number has exactly two factors. It has to be the number itself and 1. And by definition, 1 is not a prime factor because it only has one factor, which is itself. Prime factors can be written in any order, and except for the change in the order, there's only one way to write a prime factorization of a number. To get down to prime numbers. So let's look at some examples. In this case, we want to write the prime factorization of 98. We're going to show you two different ways, and whichever way works better for you, go with that. The first method is a factor tree, so let's work through that one. So let's first look at the factor tree. So we start with what number we're trying to get the prime factors for. So we start with 98. From 98, we know 98 is even, so it's divisible by 2. And 2 times 49 will give us 98. 2 is a prime number. So we can go ahead and circle that. That's, excuse me, the end of that tree. But 49 has two factors, and those two factors are 7 times 7 is 49. And again, 7 is also a prime number. So we can write the prime factorization for 98 is 2 times 7 times 7, or 2 times 7 squared. So that was what the prime factorization for 98 using the factor tree method. That's probably going to be the method most of you are going to choose to use. Coming over and looking at the method, the ladder method, again we start with the number we're looking for. Or we'll start with our prime number, or our number we want to factor, which is 98. Again, 98 is divisible by 2, so 2 times what's 98? 2 times 49 is 98. And then again, 49, factors 49, 7 is divisible by 7, sometimes 7 is 49. And that's going to leave us just 1. So in this case, we can look here, oops, should be a 7 out here. So these numbers on the outside are our prime factors. So those are going to be, again, 2 times 7 times 7, which is going to give us the same we got for our factor tree. So again, either method's going to work. This is a ladder method because you see it kind of looks like we're stepping down a ladder. So you're going to try your hand at these four. Again, try the factor tree or try the ladder method. Now we're going to look at the greatest common factor. So factors that are shared by 2 or more whole numbers are called common factors. They have the same factors there. The greatest common factor is the largest factor. So factors of 12, so we just break these down. We have factors of 12, 1, 2, 3, 4, 6, and 12. And you can check this by going 12 times 1, 2 times 6, 3 times 4. So we have them all. Factors for 32, we're going to do, we know we have 1, 2, 3 doesn't work, 4, 8, 16, and 32. So now let's look at the factor between those two that's the greatest common factor. So we go down here, we have a 4 here and a 4 here. So our greatest common factor for 12 and 32 is going to be 4. Oops, and we're going to write that down here. The factors they have in common, they have 1, 2, and 4, the factors they have in common, with 4 being the greatest factor, the greatest common factor. So let's look at this example. We want to find the greatest common factors between 100 and 60. So first we want to list the factors out and then circle the greatest one. So again, we're looking for the greatest common factors for 160. So we listed the factors for 100 and the factors of 60. Now let's see which one's the greatest one they have in common. Looking here, we have factor 20 here and 20 there, and that's the greatest one. So our greatest common factor is going to be 20 for 160. Now let's look at the second one. We want to find the greatest common factor for 26 and 52. So for example B, I chose a different method here. For example A, we listed all the factors and found the greatest common factor. For example B, I went ahead and used the prime factorization. So I took 26, and that factors into the two prime numbers 2 and 13. Those are both prime. And then 52 factors into 2, which is prime, times 26, which then factors into 2 and 13. So those are the prime factorizations of both 26 and 52. So now our greatest common factor, they each have a 2 and the 13. So each have those two factors. So our GCF for this one is going to be 2 times 13, or 26. So again, either method's going to work. You might find that the prime factorizations that we did in example B might be faster. But you get your chance. You might want to try one listing all the factors out and one doing the prime factorization. So now we can also find the greatest common factor of monomials that include variables. So we've been working with just numbers. Now we're going to throw some variables in there. To find the greatest common factor of monomials, we write the prime factorization of each of the coefficients of the number in front and all the powers of the variables as products. So we'll show you some examples of those. Then we find the product of the common factors. So here we want to find the greatest common factor for 8x squared and 7y cubed. So in our first example, we have 8x squared, and factors, prime factors, are 2 times 2 times 2 and x times x. 7y cubed factors into 7 times y times y times y. Looking at these, none of these factors are the same, so in this case our greatest common factor for 8x squared and 7y cubed is 1. Now for B, let's work through B. Set out the prime factorizations for 15x cubed is 3 times 5 times x times x times x. And for 9x squared, we get 3 times 3, and then x times x. So let's identify which ones of those factors both of these have. Both have a 3, and they both have 2 x's. So our greatest common factor is going to be 3x squared. They each have a 3, and they each have the 2 x's in there. And remember, if two terms contain the same variable raised to different powers, in this case x cubed, x squared, the greatest common factor will contain the variable raised to the same power. That won't change, raised to the lower of the two powers. So here x squared is lower than x cubed, and so it's going to be 3x squared. It's a lower term. Here are your chances. You got 3 problems to check it out. And now we have a story problem. A cafeteria has 18 chocolate milk cartons and 24 regular milk cartons. The cook wants to arrange the cartons with the same number of cartons in each row. Chocolate and regular milk will not be in the same row, so row chocolate and row regular. How many rows will there be if the cook puts the greatest possible number of cartons in each row? So looking at these, we have some numbers. She has 18 chocolate and 24 regular. So we have to get the greatest common factor for 18 and 24. So broke down, got the prime factors for 18, doing the factor tree. 18, 2 and 9, 2 is prime, 9 breaks